What is a security vulnerability? I don't think that there is an easy answer to this question, and so in this video I want to go over a few examples and share my thoughts. I'm really curious how you think about it, because my actual job is to find and report vulnerabilities, but I don't really have a clear definition. For me, it's actually often just a feeling or an intuition that I have when I determine if something is a vulnerability or not. And I hope you find these examples thought-provoking as well. Let's start with a CVE. The Common Vulnerabilities and Exposures CVE system provides a reference method for publicly known information security vulnerabilities and exposures. So if something got a CVE assigned, it could mean that we all agree that it is a vulnerability. But have a look at CVE 2018-17793. This is labeled as a virtual env 1600 sandbox escape and doesn't make any sense. Virtual env is a tool to create isolated Python environments. The basic problem being addressed is one of dependencies and versions. Imagine you have an application that needs version 1 of library foo, but another application requires version 2. How can you use both these applications if you install everything into userlib python 2.7 side packages? Also, what if you can't install packages into the global side packages directory, for instances on a shared host? In all these cases, virtual env can help you. It creates an environment that has its own installation directories and doesn't share libraries with other virtual env environments. So this just helps you developing Python programs, and I use it all the time for the reason that were just mentioned. However, I can see that maybe somebody misunderstands the purpose. The name virtual environment and it creates an isolated Python environment could be misunderstood. Also, we use languages like we enter the virtual environment, and we sometimes use shells that indicate when a virtual environment is active. So it does sound like a typical virtualization technology which we do use for security reasons. For example, using virtual machines to isolate malware. And a virtual box escape is indeed a vulnerability. You escalate privileges from the virtual machine to the host. However, here you should immediately understand that this is not the same thing. This virtual Python environment, in quotation marks, is just a way to structure Python projects, and maybe the language is slightly misleading to an outsider, but of course any code ran here can do anything. That's why also the maintainers were so frustrated with the report and why so many people, including me, joked about it. Just because it's called virtual environment, it doesn't mean there is a virtual machine with the goal of privilege separation. So here we don't have a vulnerability. Let's look at a second example. I do quite a bit of Ethereum smart contract audits, and in those audits we of course look for typical security issues like reentrancy attacks, logic bugs, and whatever. So from the ICO's point of view, they want to issue a token, sell the token for an initial amount of money, ICO initial coin offering, to raise capital and use it to build something with that raised money. And the people buying those tokens hope that whatever this company builds will cause the token later to rise in value. So from the ICO's point of view, they mostly care about bugs that would allow others to steal tokens or even just manipulate their token balance. That of course would mean huge financial losses. However, just because this is the ICO's point of view and the ICO pays for the audit, this is not my point of view. Smart contracts are meant to be decentralized contracts between different parties, so to me the point of view of somebody investing into the token is equally important. So let's do an example of a vulnerability that I find thought-provoking. Sometimes an ICO will advertise that a token has a limited available amount, a fixed total supply. But then they might implement a function on the contract that allows the owner of the contract, so the ICO, to mint new tokens. This means they can, at will, just raise the number of available tokens. But this contradicts what they promised. They promised limited availability, but actually implement unlimited availability. From the point of the view of the ICO, this is not really a security vulnerability. They are the owner, they are in control, why would they care? But from the point of view of an investor who would like to buy these tokens, I think this is a big issue. This contract is now very unfair, but the main issue is that the contract contradicts promises that were made. So the issue could be titled Contract allows to mint tokens despite claim of fixed supply. And that for me is a vulnerability. Okay, third example. A while ago, a person wrote me that they found a session account hijack or something. I can't find the original message, so I'm just telling based on how I remember it going. The person also included reproduction steps in the message. They were going like this. First, log into this site, then copy the cookie. Now imagine you go to a different computer, we use a different browser now, so we log in here with a different account, you see it here. Now we intercept this request again, but replace the cookie from the first account. Boom, we got access to the other account. When people send me reports like this, I don't even know what to say. Like it's like a DOS attack on my brain because I try so hard to understand if there is a vulnerability. Of course, there is none. This is just how cookies work. And just because you describe reproduction steps that resulted into access to another account doesn't mean this is a security issue. You just literally explained how session cookies work. By the way, this is the kind of weird crap bug bounty triage people have to read because people who don't really understand it report stuff like that. And now try to explain to them that this is not an issue, which of course I did. By the way, it was a regular PHP session ID. And the person still didn't quite get it. And they insisted this is a security issue, a session or account hijacking. They were arguing that this is just hex data, so just 0 to 9 and A to F. This is a lot less characters than a full alphabet from A to Z, and they were saying it could be brute forced. Of course, it cannot be realistically brute forced. It's way too long, and thus this isn't a security issue. But this opens up an interesting discussion. Because let's say the session ID is 1 character shorter. Do we now have a security issue? Let's say 2 characters. Let's make it shorter again. Now? 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 Well, I think we can all agree that if the session ID only had 2 characters, which means there would only be 256 possible values for a session ID, that this definitely would be a security issue. This could be easily brute forced in a matter of seconds and you could access the account. So we have this spectrum here, and somewhere this example moves from being a vulnerability to it not being a vulnerability. And I'm sure we all draw the line somewhere else, especially in those gray areas where you can argue with brute force speeds and limitations and so forth. Let's look at a fourth example, XSS. So in cross-site scripting issues, you can somehow place JavaScript into a website and that JavaScript can then just do anything in that website. So if your victim opens a site with your XSS payload, the XSS can do anything like stealing the session cookie. So one kind of XSS is what we call reflective XSS. This happens when part of the URL is directly echoed back into the content of the page. Now some browser vendors came up with the idea to implement a so-called XSS auditor. This is a best effort defense where the browser tries to look at the URL and check if it contains something that looks like JavaScript XSS injection and then see if it appears in the document itself. And then there are different strategies. The browser could, for example, block the whole page or just try to block that specific script, but this creates 2 challenges. Because people quickly figured out you can abuse that. You could, for example, take a valid JavaScript snippet from the document, place it in the URL, and the browser will think you injected it. But of course you didn't, but the browser doesn't know that, so this is a false positive. So over the years, those XSS auditors got refined, but they just can't be perfect, because the browser can only guess, and bypasses are found all the time. Though in several cases it actually does stop XSS attacks, which is arguably great for the user. However, this caused a different problem. Edge actually stopped and removed the XSS auditor, and just recently we saw another proposal to also remove the Chrome XSS auditor. And maybe you wonder why, but let's read what they say here. XSS Auditor Retirement Plan Proposal. We haven't found any evidence the XSS Auditor stops any XSS, and instead we have been experiencing difficulty explaining to developers at scale why they should fix the bugs, even when the browser says that the attack was stopped. In the past 3 months, we surveyed all Google internal XSS bugs that triggered the XSS Auditor and were able to find bypasses to all of them. Furthermore, we have surveyed security pen testers and found out some do not report vulnerabilities unless they can find the bypass to the XSS auditor. The XSS auditor seems to be a nice first defense, but it was never meant as a protection or mitigation against XSS. XSS is not an issue in the browser. The issue is the web app that doesn't properly encode output. triggering the XSS auditor means your site is vulnerable to XSS. Maybe the XSS auditor stops one attack, but it doesn't mean it can't be bypassed, or your users use an old or different browser without the XSS auditor. And now it led to a culture where clients or the defensive side say that the XSS example that triggers the XSS auditor is not a vulnerability because it got stopped. So when people try to report vulnerabilities, instead of spending their time on finding more issues, they now have to spend time over and over again trying to argue why it is still a vulnerability, or waste time trying to bypass the auditor, even though the underlying issue is the web app failing to properly encode output. I always report XSS issues, even when they trigger the XSS auditor. I don't think it's in the client's best interest for me to waste time on trying to bypass the browser. My job is to find vulnerabilities or vulnerability patterns in software of a client, so the client can fix the actual issues. That's what they pay for. I have actually a small related series to a similar topic. Check out my AngularJS playlist where I analyze a few AngularJS sandbox bypasses. Several people constantly had to find bypasses to prove to clients that by simply updating AngularJS doesn't fix the underlying issue. And this was successful. In the end, the sandbox was removed, which allowed easier XSS without a bypass because the nice-to-have sandbox was misused as a security mitigation. The client should fix the underlying issue. So this XSS example shows that even if it might not be directly exploitable because something stopped you, it doesn't mean it's not a vulnerability. And I have actually even one more example that goes a step further. So here is example 5. So there was once a mobile app which communicated over SSL with the server, and SSL was properly implemented in this case. As you know, SSL protects against man-in-the-middle attacks, so even if you somehow man-in-the-middle the network connection, you cannot see nor you can modify the messages exchanged between the mobile app and the server. We can call this an encrypted TLS tunnel. Now the messages exchanged were actually encrypted with AES in CBC mode with PKCS5 padding. And it turned out that the server was vulnerable to a padding oracle attack because there were kind of verbose errors when you sent a corrupted message to the server. I don't want to explain how that attack works here, but it can be used to recover the encrypted data. So if you could somehow get your hands on an encrypted message sent from the app to the server, then you could abuse the error messages to perform a padding oracle attack and extract the clear text data. Is that a vulnerability? That you can decrypt encrypted data? Well, we had a huge discussion about this because all of this happened inside of a TLS tunnel. So even if you were able to get a network man in the middle, there was no way to actually get the encrypted messages. SSL or TLS prevents that. Now think about that. If there were no encrypted messages, just SSL, I would never report that. It uses SSL that protects against man in the middle, this is safe. Though I argue that because the client implemented the second layer of encryption, they wanted that additional layer of protection, and breaking that layer through a padding oracle is a vulnerability. So I reported that. So now we had 5 different examples that all have something weird about them. I hope they really help you think about what a vulnerability is and how hard it is to define what that means. I don't think I have a clear definition, and if I would try to come up with one, I would find exceptions and contradictions easily. For me, it's actually mostly intuitive and a feeling. I think I know when something is a vulnerability, and I know when it's not. I would tell you that you should just read vulnerability reports to also learn that, but actually it's not easy to build an intuition because you would need the intuition in the first place to filter out the stupid reports. And I think this is what we see happening. Due to more and more unexperienced bug bounty reports, we get flooded with vulnerability reports that are not vulnerabilities. And sometimes they might even get bounty, because the receiving client might not be able to realize that the report doesn't make sense. And suddenly you normalize a certain type of finding as it being a valid vulnerability for a bug bounty. And this creates this whole weird economic around it. When at some point a site or a triage team rejects those reports because they realize it's not actually an issue, then you have people complain and point out previous payouts. It's really messy. All advice I can give is to stay skeptical about reports, and when in doubt, ask a few trustworthy professionals about their opinion. And hopefully over time you get the experience you need. Oh, and we haven't even talked about severity ratings yet. But I don't really care about that. I have a hard time to determine if a vulnerability is low, medium, high, or critical in a certain context. So I don't think that calculating a precise score like CVSS makes sense. I understand why for business tracking reasons the common vulnerability scoring system exists, but I don't know. I never used it, and I feel like something is forced to be ranked that cannot easily or realistically be ranked. Well, let me know how you feel about this. And by the way, this is my view in late 2018, and my opinions on something like this can change, so keep that in mind before you angrily explode. And now, let the Hunger Games begin.